These are by far the 3 hardest missing line drawing problems I could find. So I brought my TA Indy along with me because we might need his help, especially the second problem. This middle problem, I think if I gave this to a class, there might literally be 0 students that would get this right the first try. So if you can follow along for these 3 drawings by the end of this video, there's probably nothing your professor could throw at you that you would not be able to handle. First problem, the most common mistake that I would definitely expect most students to make would be to see this corner on the front drawing and trace it up to the top view and just draw a straight vertical line on the top view and call it a day. Right, this little orange sketch I'm drawing off to the side that's what they're envisioning in their head that this shape looks like. And that's almost right, but it doesn't account for the round shape that we see on the right side view. It also doesn't account for why on the top of the front view does that little center line right in the middle of the circle, why does that dip down a little bit? Isn't that should jump out at you as something that's kind of strange. Why does it do that? So before I finish the drawing, it will help to kind of be able to visualize just what this 3D shape actually looks like. So looking from just the right-hand view, it looks almost kind of like a barn or something. Right, just like a block with a half cylinder on top of it, just a big round surface. That's what it kind of looks like from the right. But from the front view, we can see there's a diagonal line, so picture that sort of round barn sort of shape. And why do I keep calling that a barn? That is not what barns look like. Let's go with an Airstream trailer, one of those old stainless steel Airstreams. That's what I was talking about the whole time. Let us never speak of the barn again. But if we account for this diagonal line, let's picture this Airstream trailer now with a slice taken out of it at an angle, and that's sort of what this shape actually looks like. So now imagine you are looking from the top down at this shape. From the top view, you would actually see this rounded blue line. That would all be visible from the top. And the best way to think about this when it comes to actually drawing it is that an angled surface looks like an edge on one view. So on the front view, that diagonal line that you see, it looks like a face on the other 2 views. So the exact same face that we see on the right view that's sort of like rectangular with a round top, you'll see that exact same shape on the top view, just rotated 90 degrees because of the miter line. So the bottom of this blue outline is already drawn, is just the right side of the top view. But the round surface, that's the missing line that I have to add. So like the center of this circular shape, I can trace horizontally over the front view and then straight up to find where the center of the circle would go. And then from the right view, the top of the circle, I trace again over to the front view to find out where that is and then line it straight upwards to the top view. And I can see on the top view, it's not actually going to be circular. It's going to still be an arc, but not a perfect circle. It's going to be kind of squished because from the front view, the line is not at a 45-degree angle. When you have a line that's actually like kind of steep, then your right view and top view will be the same shape. It's just one of them will be more squished. As long as you get the quadrants in the correct location, it doesn't matter if your hand-drawn arc is not perfect. Now it's pretty tricky, but your TA Indiana provided some moral support back here. It looks like he's napping, but he's helping. That's what it looks like when he helps. And so for drawing number 2, we're definitely going to need his help. Look at this beast. There's so many triangles. It's hard to even tell what's going on. And I know from the front view, because of this rectangular cutout, there's a couple of corners here that can trace upwards. So I know there's going to be something going on up there. But I just need to figure out what's even going on in this shape first. Right? I'm having trouble even just imagining it in my mind, just visually, just the spatial reasoning of it is challenging. So looking at these 3 red circles, these look like they're probably an oblique face. Oblique faces are sort of angled, but they're angled in the X, Y, and Z direction, so you can actually see the shape like from all 3 sides. So if I envision this total object as something having a flat diamond on the top, and then sort of 4 triangles kind of flaring outwards from the top down to the bottom, that seems to match what's going on in this drawing. So like on the right-hand view, that would mean the middle triangle is just a flat vertical face, again with the side triangles being the ones that are kind of diagonally upwards and inwards. So instead, here's an Autodesk Inventor drawing to show you what this shape actually looks like in 3D, which is a million times better than I could draw by hand. And after seeing that, so you can see then on the front view, it looks like, again, this middle triangle is a flat vertical face and the sort of side triangles are angling inwards. And that's going to make that rectangular hole kind of tricky because it's not just cut through a vertical surface, it's cut through an angled surface as well. And so there's definitely going to be a lot missing on the top view where the hole passes through the angled triangle. I already said that oblique faces are visible from all three sides, front, top, and right view. So instead of viewing these as a triangle with the cutout, let's actually just look at this blue shape, just the four-sided quadrilateral, right? So points A, B, C, and D, they should be visible on all three views. And if I find points A, B, C, and D on the front view and right view, I can reflect them across the miter line and match them up to see exactly where they'll be on the top view. So I can finish the top view then by just connecting the dots. So I think most students wouldn't even get this far, but for students that do, one of the real tricky parts is matching up like points A and B on the front view to the right view. A and B on the front view kind of look like they should line up with C and D on the right view. But remember that A and B, since that center triangle is vertical and flat all the way on the very front, on the right-hand view, the front of the right view is all the way to the left. So that's why A and B are stacked right on top of each other, all the way on the left part of the right view, because that's the front, which is where they are on the front. So then points C and D on the front view are on the left side, but because it's sort of angled back, that means on the right view, points C and D are kind of more in the middle. And so, if I use the miter line to trace some construction lines across, identify points A, B, C, and D on the top view, the two that aren't connected but should be are points B and C, right? That's where the hole is cut on the front view, so points B and C should also be connected on the top view. And once I draw that, I can draw one more line that's kind of a mirror image on the top part of the top view. Because the hole goes all the way through, it's not only causing this one ABCD quadrilateral on the front of the part, there's another version just like it on the back side of the part also. And I can repeat this exact same process for the little triangle that's all the way down in the corner at the bottom. So I create points A, B, and C on the front view, and based on those labels, A and C are actually flush at the very front vertical surface. So on the right view, those will both be all the way to the left-hand side of the front view. And point B is actually the one that's kind of horizontally aligned with A, but set a little bit further back into the page, which is further to the right on the right view. Again, use the miter line and trace these points and connect the dots and put them all on the top view. And again, there's one more diagonal line to draw on the top view to connect points A and B, which are the points on the front view that were connected horizontally by the hole that was pushed through. And I can draw this also again on the top side because this rectangular hole does go all the way through the part. So not only does it cut through the front triangular surface, it also cuts through a triangular surface further back. And with all of that, you would think surely this problem is done, but sometimes your professors are just out to get you. So of course there's one other missing line. And if you look over on the right side view, right, there's dashed lines that go all the way across to represent the hole that's hidden, because right in the center of the part, that's where the edge of the rectangular hole is. So there needs to be a hidden line right slice through the middle of the part. And if it helps to think of this as a rectangular face, right, this hidden rectangular face that's like the top surface of that rectangular hole, corresponds to this blue rectangle in the top view, which you can see lines up with these lines on the front and right side view, right? A horizontal surface looks like a face on one side and an edge on the other two sides. That's the difference between that and an oblique surface. The oblique surfaces look like faces from all three sides. They didn't look like an edge on any of them. So if you think to yourself, wow, I would definitely have missed that on a quiz before, but now that I've seen it and I kind of know what sort of things to look for, then go ahead and leave your TA Indy a thumbs up. He looks like he's just napping, waving his tail a little bit here and there, but he's helping. This is what it looks like when he's helping. And if you're really learning a lot from this video, then maybe send it to a classmate of yours. If you think they could use some help as well, go ahead and forward a link to this video to them as well. So last problem, and I'll apologize in advance, this is really hard to draw, right? So you're gonna have to use your imagination a little bit for these like squiggly lines. Drawing a round hole is hard enough, but try drawing a round hole through an oblique surface. It's a totally weird shape, and I did my best. But setting aside my wobbly lines, there's still a question of what is missing from this drawing. But before I even get to that, it may help to visualize why are these circles so weirdly shaped, right? And if you see these three red triangles, you'll see again, it's because there's an oblique slice cut out. So if I just start with a box with like flat vertical and horizontal faces and sort of connect the top left, top back right, and a bottom front corners to each other and make a triangular cutout, that's the main overall structure to this shape, right? That way you would see all of these triangles from all three perspectives. But then if you consider that there were a hole cut right down vertically through the middle, then all of a sudden my hand sketch sort of fails to really capture what that shape would really look like. This is pretty horrible drawing. So again, I've reverted back to a 3D modeler. I drew it up in Autodesk Inventor, and let me put that up here on the screen instead. That is what this shape would actually look like in 3D. And you can see when you look at it from the front side and from the right side, yeah, you get this weird sort of oblong, sort of quasi-circular kind of shape. But back to the front, top, and right side views, what's really missing from this drawing is hidden lines. If this circular hole is drilled straight down, on the front view and the right side view, we should see hidden lines for the left and right side edges of the hole. So from the top view to the front view, I can trace some construction lines straight down, marking the left edge and right edge of the hole. And on the left edge, I can just trace from top to bottom because the left side of the hole is all the way at the top. But the right side of the hole, and this is probably the most common mistake a student would make on this one, the hole is not all the way at the top of the shape, right? Because of the oblique cutout, it's dipped a little bit lower. So the hidden line, the hole at the edge, would actually start at that quadrant. Like it starts partially down the drawing, not all the way up at the top. And again, because at that point of the drawing, the top is just the flat top triangular surface. The hole is in the middle of that angled face. And so this front view looks really strange. Like the circular hole is not circular. And the left-hand side, the hidden line starts further to the left than the hole even is. But that's because when drawing the front view, where the curve intersects the top of my front view is not actually the leftmost part of the hole. It's where the circle, sort of where the oblique surface intersects the top view, which is close to the far left side, but not all the way to the left. To draw the hidden lines on the right-hand view, I'm going to start off with a miter line, and using the top and bottom quadrants of the hole on the top view, trace those across the miter line and then down to identify the left and right boundaries on the right side view for the hole. So just like the front view is looking kind of weird, the right view looks just as weird as well. On the right side of the right view, there's a vertical line that goes from bottom all the way to top that like doesn't even touch the edge of the circle. That's because this circular shape doesn't intersect the top view at the quadrant at the extreme edge. It intersects where the diagonal oblique surface reaches the top. And then the short little stubby missing line, it also doesn't intersect the drawing, but that's just because my drawing's bad. It should, like the curved arc should intersect my missing line. I think my hidden line looks good, so I'm actually gonna just redraw the arc a little bit to be at the right place. Yeah, and again, I'm tracing this orange line straight up and then straight over across the miter line to the top view, so you can see that where this weird arc on the right view reaches the top, again, it doesn't correspond to the quadrant. It corresponds to the part of the circle that intersects the top edge of the oblique surface. So a brand new engineering student is probably going to have a little bit of difficulty just figuring out how to draw rectangles and triangles. The common theme that made these drawings in this video really hard is that they were intersected through oblique surfaces or rounded surfaces. So you've made it through the hardest missing line drawings that I could probably ever throw at you. So if you want to maybe step it back a little bit and get a little bit easier practice where you can get through more drawings faster, then click on the video on the screen here. Same sort of principles and tools are used, but difficulty is a little bit more reasonable, probably more in line with what you would actually expect to see on your homeworks and tests.